Okay, welcome back. So, we have a problem here. What is the derivative of this function? F of x equals x squared. And why did I choose x squared? Because it's simple. And I'm going to show you with a very simple example. The book does this too. And you can, if you like the book, you can follow along with it as I explain this to you. So, there's two ways you could figure out this. And one of those ways involves using the power rule, which is and the derivative rules of differentiation found in the next chapter of our learning. And honestly, I prefer that because it's much easier to look at this. But knowing the formula of a derivative and its definition is very useful when you have a function that isn't nice like x squared, or is like, crazy, like some, has like some strange irrational number or something. I don't know exactly when it'd be more useful to use the formula than it would to use the rules. But I'm going to teach you how to do both, and you'll find that using the formula is actually much easier. I'm going to do that after I check on my son. I have requested Charlotte's help with little Leo because he is just not happy tonight. He's his top two teeth are coming in, and it's hurting him. But he just had Tylenol like 2 hours ago, so we can't give him it again for another like 2 hours. So anyway, okay, so we're gonna find the derivative of this using the formula. Like I said, I like the power rules better, but the formula is gonna be how we're gonna do it. Now, one thing I like that the book really does is it talks, actually the book doesn't do this, I'm sorry. The homework really does is it talks about the 4-step process. Now, that's a really great idea, but what the heck is that? We haven't heard about that in lecture. We haven't read that in our book. What the heck is a 4-step process? Why are they asking us questions about a 4-step process when no one's told us about it? Well, here's your chance. The 4-step process is basically taking the formula for derivative. I'm using h here because h is my friend. The limit of, as h approaches 0, of f of x plus h minus f of x over h. And I'm breaking it up into smaller chunks. So what you're going to do is, step 1, you're going to evaluate f of x plus h, or x plus delta x if you like to use that. So all you're going to do here, just remember, this is x plus h is an input. Treat it as if you would any other number. F of 5 would be, you would input 5 for x. F of 23y would be, you input 23y for x. Whatever value is inside the function is what you put into it. So this is our input. So you take the original function x squared, and wherever you see x, you're going to put x plus h instead. You're going to replace it with x plus h because it's no longer x1, which is the point. It would be x2, which is x1 plus some tiny distance traveled, or an infinitesimally small distance traveled. And so that's all you're doing, is you're just plugging that in. So step 2 would be adding y1, or f of x. Or I should say subtracting. I mean, like, including. I should have said including. Step 2 is including y1, or f of x, into our little thing. So we're going a step further. We're taking whatever we got in step 1 equals some value, and then we're taking this value and we're putting it here, and then that minus f of x. And for that, you just replace that with your original formula here, or your original expression. And then, sorry, and that equals some expression or value or something. So the third step is you're going to divide it by h. You're going to take whatever was here, f of x plus h minus f of x quantity over h. And that equals some expression, and it's going to be long. When you're doing things like this, especially when you get polynomials where it's x squared minus 3x1 plus 13, you know, that's going to be a little bit, there's going to be a lot more numbers, and it's going to freak you out. But just remember that it's not as complicated as it seems. Yeah, there's a lot of algebra, too much, in my opinion, but it's actually, the concepts are really simple, and you just have to remember that this formula isn't so big once we break it down. I mean, it's still big, but it doesn't seem as big. And the fourth step is taking the limit as h or delta x approaches 0 of this value here, or expression here. So the limit of f of x plus h minus f of x, running out of room here, over h. And that is your derivative. So that's what the four-step process is here, and I'm going to use it because it makes the algebra seem a lot less daunting. Just know that it's going to be rather long. Okay? I will see you in the next video.